So I've been building an application at TechSpace, and I did the same thing. I did naive RAG for a while, and it didn't work. I tried multi-hop, which is you break the query down to multiple queries, and then you do all those search on their own, and then you bring all them all together, and then you do rerank. That kind of worked, but whenever I search for something that's very particular, like something that the embedding model wasn't trained on, it's pretty bad. Like, for example, if your text corpus is all acronyms, then if you do similarity search, you're not going to find anything. But I want to tell you why this topic is important, not because of my personal experience, but also, yes.
All good?
All good, all good.
Do
you want to join us?
People up if they come in
Thank you.
workshop.
Thank you. Okay, so everybody knows this guy, right? Perplexity, $2 billion now, I think, or $1 billion valuation. Supposed to overthrow Google as a new search engine. But essentially, they scrape the web, and then they run whenever websites they hit, they just go into that website and they scrape it quickly, and then they do RAG over it to give you a straightforward answer. So that's cool and all. It works most of the time. We don't know what's happening behind the scenes at Perplexity, but the CEO of Perplexity said that vector embeddings do not magically solve search. In fact, the heavy lifting is in the step before you re-rank with semantic similarity search, making a genuine improvement over BM25 or full text search is hard. So BM25 is an algorithm to rank search results using sparse vectors, which is different from dense vectors, which is what we would use to create embeddings for our RAG system. And here's another example of companies that are at the cutting edge who are saying that, similarity search is cool. Like you search for synonyms and stuff. You get a broader search result as long as your embedding model is trained on that, on those terms. So news articles you can easily find the similarities between articles, but legal documents not so much, unless you have a particular embedding model to embed all that. So that's where hybrid search comes in. So hybrid search is essentially keyword search. So your regular, type in your search box and you get the exact stuff back, or partial of that. You can't search broader than that, like a similarity search. However, it's very useful when you combine the two. So what we're going to do today is we're going to take a sample data set of legal cases. This is just a data set that I got from Kaggle. Is it Kaggle or Kaggle?
Kaggle.
Kaggle. There you go. And I just went through it and then get 1,000 rows, and then we can just embed all of that and test between pure similarity search and sprinkle a little bit of keyword searching in there to see if we get better results. How's everyone doing so far? How are you doing so far?
Okay, yeah.
Okay, let me know if you need anything.
Thank you.
Awesome. All right. So this is legal text classification data set. So it's just case ID and then case name, what happened in the case, verdict, and that's it. Just a CSV. So we're going to download this data set. Anyways, we got the data set. Now we're going to get, thank you, ex-Google engineer. Thank you. So we're gonna get this package so I can display my data in a nice table. Okay, so that's done. All I'm doing here is just create my table. Very simple. So this is what my data looks like. So we got case ID, case outcome, which we care about, case title, and case text. So this is the text of the legal case. This is actually what we're going to be using to create our embeddings. And then we're going to try to search over this using naive RAG, and then we're going to do a keyword search combined and see what comes out better. Okay, so 1,000 rows, that's fine. First things first, go to get the OpenAI SDK. I guess there are other options out there, but I like their embedding models, V3 large and V3 small. Here's my OpenAI API key. If you're quick, you can just
Got it.
snap it. Let's take a mental photograph of that.
I mean, it's in the recording, so we're fine.
So in my Notion, I have like 10 to-do boxes that says like rotate this key, rotate this key, rotate this key. So you gotta beat me to it after this. Okay, so the reason why I'm installing LangChain OpenAI here is not because we're gonna be using LangChain essentially, but I'm gonna try to half the number of dimensions in my embeddings so that I can just want to show you that you can do that with the very capable embedding models like V3 large. So OpenAI came out with 2 new embedding models a couple months ago, and there's a V3 small, V3 large. They all beat 8.2 by like a huge margin. V3 large, you can reduce the number of dimensions from like 3,000 something to like 256 and still get better results than 8.2, which means if you want to save money like I do on like on your databases or your Pinecone pod, you can do this and save a ton of money because 256 dimensions and perform the same way as 3,000. That's way better, right? Although you're paying 10 times more than V3 small.
In fact, that's the internal service that OpenAI has, Assistance, which allows you to do this. You can upload documents, and they'll do sort of RAG for uses exactly V3 large at 256 dimensions. They use it internally.
Wow. What a ripoff, huh? They don't even use the good stuff. Anyways, so I'm not going to go to 256 actually. I'm going to go to, actually I didn't know that. Thank you for telling me that. So it's legit. However, I did this really dumb thing recently. Well, not recently. But I had it for like 2 weeks, where I have the number of dimensions on the small model, and then my system got like a lobotomy, and it didn't work at all. And I'm like, are they lying? Like, why am I not getting the results? Turns out I was using the small model.
Wasn't that at the demo or something?
Yeah, I was on customer discovery calls, and I'm like, wait, why is this so dumb? Like, let's start questioning my whole like architecture. But I realized that I used the wrong model name. Anyways, we're going to be using LangChain because welcome. Grab a seat anywhere. We're going to be using LangChain because when you reduce the number of dimensions for your vector embedding models, you have to do some math. I don't know how to do math, but in LangChain it wraps that for you. You just have to pass in your dimension number, and then it'll just calculate all that for you. So it gives you a nice embedding client too. So you can just call it. We're going to get tick token. Tick token is just a library that OpenAI made that can tokenize like all their GPT models, basically. When I was going through this workshop, so now what we're going to do is we're going to create this just utility function to create our embeddings. When I was going through this, I sent this to my friend Cyrus at Nokia, who's an AI engineer, and he told me that I don't have to embed every single row on its own when I send to OpenAI. What I could have done was I could batch them. So you can instead of sending one string to OpenAI API to get embeddings back, and then in this case I have to send 1,000, which took like 50 seconds or something. I could have just grabbed all those strings, put them all into a list, and send them all together, as long as the total tokens in that list is less than the total tokens. That's in the context window of the model that I'm trying to hit, which is V3 large. Then I can just get them all at the same time. And I went from 50 seconds down to, actually I can see the comments here. I went from 50 seconds down to 88 seconds down to 0.8 seconds. So it was almost instantaneous. As opposed to before when I was like, oh, I just gotta wait every row. And then I was like dumb, I put in some randomizer so I don't like overload their API endpoints. Like, yeah, just don't do that. Batch it, you can do it. Okay, so we got the embeddings. No, actually we got the utility function. Now we're gonna just generate them. Text is too small, I can't. Okay, so we're gonna try to generate embeddings for like the first, how many rows here? Can't even tell. 3. First 3 rows. So same table that we just saw earlier, but we got a new field called embeddings. So it worked fine. This is 512 dimensions. So now we're going to run it for all the rows. See how quick this is for 2 seconds. 59 batches, and it costs this amount of money. Forget what I just said. So we got the embeddings back. We paid like less than $1. Usually this would have taken probably 10 times longer, but we can move on now. Okay, so to test similarity search and hybrid search, I'm going to be using your most popular like off-the-shelf vector databases that does this. So we got Pinecone. Obviously, Pinecone is state of the art. We got Weaviate, which is the challenger. And we got my favorite setup, which is Postgres, PGVector, and a Reranker, which is your poor man's setup. And I will show you how my setup doesn't even go anywhere near their stuff. But first, we're going to set up Pinecone. Anybody here not know what Pinecone is? Okay. So Pinecone is a vector database. I actually don't know what's underneath it, but it allows you to store embeddings, which are just arrays of floats, and then help you query those very effectively. Do you know what's underneath Pinecone?
No, it's a cloud service, so it's not available.
Okay.
It's a pure vector database. It doesn't do anything else.
Yeah.
Unlike Postgres, which does a few other things.
Mm-hmm.
Yeah. Postgres does everything.
Yeah.
If you don't have money, like I do, but I don't, then use Postgres. It just takes a little bit of time to set up. Pinecone developer experience, though, amazing.
It is.
Like you just go in, you don't have to like throw in API keys. They have like their own like Colab wrapper. You just go in, authenticate. I get an email. That's it. Yeah. That's why I've been shilling them this morning. It's great. Anyways, we got Pinecone. Set up Pinecone client so we can create index, upsert, and query our embeddings. Very simple stuff. So that's all we're doing here. Creating an index so that we can store our embeddings. You always have to specify like how many dimensions you want the index to be. And then one thing that kind of stood out to me. So you have to use the dot product metric on Pinecone to be able to try similarity search. I mean, hybrid search. The reason for that, I actually don't know. But for Pinecone, you had to send in 2 types of vectors. You had to send in the dense vector, which is what you get from like V3 large, V3 small from OpenAI, like your traditional similarity search embeddings. And you're going to send in sparse vectors, which is what you can generate with BM25. And you're going to send them together so that it can do the search for you. And then what you can also do is create like a fusion function to kind of like calculate an alpha to see like how much you want to weight against like the similarity search as opposed to keyword search. So you can have like a threshold of like, I want more similarity search than keyword search, or I want more keyword search than similarity search. Because in the real world scenario, we don't know which one we need, right? Otherwise, we just use the tool for the job.
So how is it using the 2 embeddings? Is it like concatenating them, or because the dot product is still between the query and the document? So how is it using like the BM25 and the dense vector? So you're saying that it's separately doing like dot product between the BM25 or the query and the documents and the dense, and then maybe like seeing which ones are the retrieved in both cases, and then.
I think so. I think they always do like separate and then re-rank internally somehow.
Yeah, because like the embedding spaces will be so different between like a BM25 and your dense embedding. So I was just wondering how they're using them together.
In your responses you get back from Pinecone, in this case, you get both dense and sparse results, or do you use a separate query?
For hybrid search?
Yeah, for hybrid search.
I just get back documents.
Right.
Yeah, and there's a relevancy score too, which I don't know if that means, similarity search like distance or sparse factors. But here, let me show you what the fusion function looks like. So BM25, you got to train it a little bit. So I have like 500 legal text case train set. So I'm just going to use to like kind of fine tune my BM25 a little bit. And this is all like wrapped in Pinecone too. So it's pretty straightforward what you have to do. Also super fast. Okay, so this function only just groups them all together. And then let me see what the so the fusion function will be towards the search part. Now I'm just going to show you how to generate the embeddings. So what we did was we generate both types of embeddings, sparse vectors and dense vectors. Sparse vectors using BM25, dense vectors using our traditional OpenAI embeddings model, V3 large. And then now we're just going to group them all together into like a nice dictionary. So we got the sparse values here, and we got the embeddings. How's that sound? Any questions about anything? I was going to say, if you have any questions, just direct them to Chris. Okay, we're going to upsert all of our embeddings. So we're going to upsert both sparse and dense. We're not going to do one or the other. Okay, so we got everything up. We got the embeddings, both sparse and dense, on our Pinecone instance. Now we have to create a utility function to just convert our query, which is usually a string, right? It's like, what happened in this case? Turn that into both dense and sparse vector. So we can do similarity search on its own or hybrid search, which is keyword and similarity search. This is the stuff that I'm talking about. Hybrid scale. Okay, a lot of math. If you understand this, you gotta let me know, because I copied this directly from the cookbook. I don't understand it at all. But what I do know is it gives you at the end, it gives you an alpha, which is, no, actually, it gives you like a fusion of dense and sparse vectors.
And do you pass in a fixed value to it?
Yes. So you pass in a number, which is a float, and then
That's the bit that decides which
Yes.
of which, yeah. Okay.
so it goes from 0 to 1. If you want all similarity search, you set it at 0. And if you want all keyword search, you set it at 1. And I'm assuming if it's all keyword search, and it's probably just like a normal database behind the scenes, right?
I guess this could be extended to all kinds of embeddings, right? You don't have to have just BM25 and dense embeddings. You could then have different kinds of embeddings. So you could have a byte pair embedding, you could have a sentence piece, so on and so forth, and just combine them, I guess.
Yeah, but you just can't use Pinecone for that. You gotta whip up your own stuff, like PGVector. PGVector plus something, because then in Postgres you can do TS vector for the full text search stuff. So you gotta set up your own stuff, because Pinecone, it wants very specific things.
Or you can use Elasticsearch, which just has this all built in.
Oh, you just write a line.
But if you use hybrid search and Elasticsearch, it already does BM25, or you can choose an algorithm and it'll just return it for you. You don't have to embed. You don't have to do.
You don't have to generate, right?
You don't have to generate the sparse vectors.
That is super
it does
cool.
it for you.
That's super cool.
That's what it's always done, and now they've added the.
Oh, so they're the first mover.
Yeah, and then it comes back and you get a combination of similarity and lexical search results and they're ranked in the response.
Awesome.
That's how I've done it. How I've done hybrid search with Elasticsearch.
And I thought this was the next new thing, but Weaviate does the same thing, so you don't have to generate sparse.
Yeah, probably.
So
They seem to stress more the traditional search coming from the traditional search background.
interesting. That's the sense that I got from using their stuff. But here you gotta do everything by hand for some reason. So we got Pinecone set up. Now we're gonna set up Weaviate real quick. Weaviate is like Pinecone, but I don't know if it's better. It's the same thing. Vector database.
There's not much difference between them. I've not used Weaviate.
Yeah, apparently Weaviate's marketing is pretty interesting. They seem to really be targeting developers as opposed to Pinecone's enterprise and look very polished. We'll probably just ignore these errors. I've seen them before. Set up a client, API keys. I had get pass and all that stuff in here. I'm this is a long collab. I'm not gonna go back and forth and copy and paste. I'm just gonna take a hit and just leave my keys on there. Okay, so we're going to create a Weaviate collection. They don't call them index, we call them collection for some reason. And when you create a Weaviate collection, you got to like specify what metadata properties you want to set beforehand. Unlike Pinecone, where you can just put metadata wherever, like kind of like a MongoDB. Like it's pretty flexible, but not Weaviate. Okay, so we got Weaviate client up. Again, Weaviate is kind of like Pinecone. So you use one or the other. From my experience, Weaviate's documentation is a little bit harder to navigate. Pinecone has a lot of content on YouTube, so it appeals to my generation. Okay, so just upload a bunch of stuff to Weaviate. Basically, it uses the same embeddings that we got before we set up Pinecone, and just upload them all to Weaviate. We didn't have to do sparse vectors, probably because they do the same thing as Elasticsearch, which is awesome to know. Apparently, bad documentation is not the sign of like a bad product. Anyways, cool. Okay, so what we're gonna do now is we're gonna set up this query. So I pick a very specific text. It just says that I'm looking for something from like the text that mentioned Palmer J in wherever party. What I want to know is it has to return case ID 269 back, because that's where I got the information from. Okay, so set up my query, and then I'm going to show you where it is. So case 269, that's where they get the text from. We know it's been embedded. Well, it doesn't show here, but this is the original data set. Now we're going to convert our search query into vectors. And this function that I made before converted to two types, sparse and dense. So you can use it on Pinecone. OK, let's try only similarity search, starting with Pinecone. We're going to get the hybrid scale fusion function, trying to get the weighted dense and sparse vectors out. And then we're going to run our query embeddings, pass our query embeddings into our Pinecone client, and then just try to get like 3 results back and see like, what comes back. So we got 119, which is obviously like not even close. 223 and 759. So like similarity search alone, not even close. And it's got a pretty good score too. So didn't work. OK, so I've got Weaviate now. With Weaviate, we're going to do the same thing, which is pass in the dense vector that we just generated from our query into a Weaviate client and try to do a query. And let's see what it looks like. You can tell now I'm like, I did this like a night ago, and I was like, I got to finish this stuff, so I'm not going to use tabulate or anything to make it look pretty. It's literally just an object back. But essentially, we got case 119 again, so it's actually kind of similar how the two vector databases got the results. Same embeddings model, same, I guess, query technique. So, sucked. OK. Hybrid search. This is the fun part. Hybrid search, passing for Pinecone, passing both dense and sparse vectors in. And we get the 269 back right away. So that was the case that we wanted. And our alpha, which is kind of like a weight number, was 0.5. Now, I don't know what's happening behind the scenes, but in my brain, I'm thinking half keywords, half similarity search. You guys want to try a different number?
I want to try 0, just to know if it's just using.
I think 0 is similarity search. No,
Just a
keywords.
lexical one, I would
Keywords only, yeah. So
What's the relevance or similarity score? Do you have that?
it's actually not as high as before.
Even though the keyword appears in the text.
Yes.
assume.
It's literally this part right here.
Yeah. It's just not that sure of itself.
Yeah, so don't trust that score. What I found is that I don't trust the score, but when I throw stuff into like a reranker, like Cohere, it actually scores pretty accurate.
Yeah, from what I found, the similarity scores will differ on embedding models and things like that. There's relative stuff, but if you use a reranker like Cohere, then it does normalize the scores. Because it's the same model, and it behaves the same way.
So put 0.8 in here. That's weight more towards similarity search, and now we got the same result as like pure similarity.
And what's the scores?
Actually pretty low. What's considered as a low score? Actually, I don't know.
But on the previous one, we had a low alpha. The difference between the winning and the lower ones was quite significant. Like,
Yeah.
there was more divergence. The other ones were all grouped similar.
Cool. Any questions so far? All right. So in a real world scenario, we don't know what's better, right? So I guess we just set it at 2.5 and hope for the best. Okay, Weaviate alpha 0.5 again. No surprises here. We got the right case. Boom, just like that. I think you were gonna say something. Okay, cool. Yeah, Weaviate works exactly the same way. Okay, this is a glimpse into my own setup. Postgres, PGVector. PGVector is a extension to do to insert and query embeddings in Postgres. So it's free. You can web up your own Postgres. It's completely free. I personally use Supabase, and Supabase has a lot of support for these extensions. So they also have built this open source project called Vex, which is a Python library that allows you to query embeddings in a more ergonomic way. Kind of like what we did with Pinecone and Weaviate. Just a couple lines of code, you get embeddings back. In Postgres, you gotta write like SQL commands to do that, and like what's it called, RPC or some gRPC or something. Actually, we don't have to write SQL if we use Vex. It allows you to just pass in basically dense vectors, upsert it, and then query. The interface is very similar to Pinecone, so it makes your Postgres looks like Pinecone. Today I'm going to be using Supabase because I wanted to set up my own Postgres instance, but then it's just too much work. Supabase is a backend as a service platform. It has Postgres built in as authentication. You click one click and then you have a Postgres database running, SOC 2 compliant, if you pay $25 a month. It's great. So we're going to be using that with Vex. So Vex, again, love the people who built Vex because it makes my life so much better.
You don't like writing SQL?
I use AI to write SQL. who else uses AI to write SQL?
No, but I learned SQL at 40 years old, so there's still time.
That's true. That's true. That's true.
A couple years anyway.
Whew. So I'm not going to show you my my Supabase project, but you can trust me. I took a screenshot of it. I basically inserted all of the original data up to this Postgres database, and all the legal cases, all that stuff. And the reason for that is because we're going to be creating two schemas in our Postgres. One is your traditional Postgres schema, which is public, which is just a table of like legal text case. And the other one belongs to Vex. So Vex, behind the scenes, just a Postgres table, stores all of your embeddings, but it puts an interface in front of you. So it acts like Pinecone, SDK, basically. And we're not going to be using the embeddings table to do keyword search, actually. We're going to be doing keyword search on top of our like your traditional public schema Postgres table, which is a legal text table right here. So traditional rows and columns, but we're going to be doing keyword search here. And the keyword search in Postgres is called full text search. Built in, super powerful. You can search in the format of a web search, which is kind of normalize your query. You can search by phrases. You can search by verbatim, basically. Like you need the whole thing to look the same. Web search type is just very similar to how like a web search engine works, which kind of like reduces like your plurals to your singulars and like normalize all the lowercase and all that stuff. Does all that for you. So again, remember full text search in Postgres plus PGVector to store embeddings. Now we have a very similar setup to our Pinecone hybrid search and Weaviate hybrid search. Okay, you can see my database string here with my password as well. Don't worry, I'm gonna rotate them later tonight. And we're gonna like just basically upsert the whole like embeddings that we generate in the beginning up to our Postgres database. And then what we're gonna do is, actually now I'm gonna upsert. Okay, similarity search in Postgres. So we pass in, again, the search query, dense vectors. And as you can tell, without Vex, this wouldn't have been this clean. I love Postgres. And I love Vex even more, because I'm a noob at databases. So we run this. Again, very similar results, right? Like we got case 119 again, similar to like Pinecone and Weaviate. However, so now we're going to do keyword search. So however, there's this one thing about keyword search here, which is that when you do keyword search in Postgres, it has to be very precise. So that's one downside compared to Pinecone or Weaviate, where you can just pass in an alpha number, and then it can kind of just can tell what to search from there from your keywords. Here, at least in my normal setup, what I have to do is I have to use LLMs in the beginning to kind of like extract out keywords, and then use those keywords to do keyword search or full text search in Postgres. I couldn't just pass in the entire query like, what is so and so and so and when and where. And maybe there's something that they're doing behind the scenes at Pinecone or Weaviate that kind of like makes that keyword search part a lot easier. Because here, what we do is we do the search query right here, and we get nothing back, even though, the entire search query, like the text, the string, not the dense or sparse vectors, the text was passed in. We got nothing back. And then just to demonstrate how I actually do it in real life, you gotta trust me on this, but like I would take the query from the user, and I will use LLMs, GPT-4o most of the time, and use JSON mode to kind of like just get the function calling, to get only the keywords from that search query. And when you like are very specific about this, and you can use like NLTK, and you can use any like other tokenization or like NLP libraries to do this. But if you're very particular about how you extract out your keywords, then you get much better results. So as long as you only have like just the right keywords, then you get the right results back, which is in this case 269. We passed in the whole thing, we couldn't get anything back. So that's one downside. That's your poor man's like setup. That's my setup. And to make it better, use LLM, use whatever tools you have to get just the keyword to do full text search. Any question about anything? Yes.
Can you do the hybrid thing?
Well, this is.
Because here you're kind of doing it separately.
Yeah. Oh, yeah. That's right. One last step. We got rerank. Reranker. Okay, so I didn't go with Cohere rerank, even though that's what is in my app. I use Jina AI. Jina AI does not have an SDK. You gotta call this REST endpoint by hand, manually. And according to my generation, we call this raw dogging. So you gotta pass in your headers, your authorization, your bearer, and your like tokens and everything. And just like it's 2024. Anyways, you can tell I was not happy about this. I was like, what? No documentation site either.
It's just one page.
Just one page,
Yeah.
landing page.
One lovely, lovely page. Yeah.
Have you tried renewing your token?
No.
Adding to it? Or your key so you can do more? It's,
Oh,
Oh, yeah,
it
it's
feels like a
amazing.
crypto site or
I
something.
know.
like
It's
that.
an amazing
I don't-
interface.
Yeah, terrible interface.
That's
I,
right.
I love it. I
Oh,
think
do you?
It's great. Yeah.
I don't know. It seems sketchy to me.
You have it in production, which is crazy.
But yeah.
But yeah, you refresh the page and it gets you a new API key. It's like, what?
And then yeah.
Anyways, we're using it today.
Yeah.
Say whatever you want, but they're doing cool work. So,
They are.
so first we're gonna merge all of our results back, right, together. So we can pass them all to Jina and we can get back a ranked search result. So just gonna merge them all here together. And then the funny thing about Jina, again, my gripe, with Cohere, you can pass in a whole dictionary with metadata, everything. You tell it what metadata you want to rank by, what metadata you want to rank as a secondary, which is great. Jina, you pass in a list of strings and you can like couple together afterwards. It's not like, you can pass in the whole object. But in Cohere, you pass in whatever you want and you get back exactly whatever you just passed in, plus the index of where it should be on the re-ranking list. Okay, so a moment of truth. I had a lot of issues with Jina being like down, but we're just gonna run this. Okay, cool, super fast. First result from index 2, which is the last one. So we had 3 results from both similarity search and full text search from Postgres. Index 2 is number 3, which is this one. So it ranked it first. Yeah. And we got a relevancy score here too, which is 0.6.
Sorry, can you just describe again what re-rank is actually doing? Because it's different than everything else you've done so far, right?
Yeah. So let's say you did keyword search and you did similarity search. You don't know which one's better. You get like 5 results here, 5 results there. You group them all together. You send it to Jina AI. It runs the embedding model. And it's like, OK, this one is most relevant. This one is less. This one's less.
You have to send it the whole text of everything, though, right? For it to figure that out. Like, these are all the results.
However much text you want.
Yeah, okay.
You
It
send
doesn't have any
You send it the
backend.
query,
Yeah.
the query plus all the results.
Yeah,
And it'll
okay.
re-rank them by
Oh yeah, that's right.
relevance
That's it. Yeah.
It's
to the
it's
query.
totally stateless. There's no yeah.
You still have to send in the text query too.
Yeah. Yeah.
Yeah.
Right.
It works the same with Cohere rewrite as well.
Does it use just the confidence to rank just based upon the confidence of the
I believe so. Let's see what the other results get in confidence. So I can change this to, so I have my top K to be, I think 1. So I'm just going to set it to 3 and see like how it ranked the other ones. Boom. Okay, so same text, index number 2 is at top. Similar score as before. But the other texts actually score really low, which is good.
Yeah, that makes sense because they don't talk about that case, right?
Yeah. But the heavy lifting was actually like, the
I
similar
like to think of
search.
a re-ranking model as a specially trained model that all it does is determines how relevant the results are to the question. That's all. It's
Yeah, and traditionally people would use BM25 to do this.
but it's more of an LLM type model that's trained on corpus to do that.
Yeah, and in your system, at least in mine, I also have a threshold where I can just reject results if they fall under like a certain number. And which is really nice because you can tell your user that, hey, we couldn't find anything, instead of like letting the LLM kind of come up with something like silly. Last slide, we got Jina status page here. So they don't even track like their incidents publicly until recently. I told Bob, I was just like, oh, it's like just a couple of cases, right? But they didn't track before, that's why. So this was when I was building this. And it was all yellow, right? It wasn't green. And I was like, is this service even real? Like, none of this is working.
It's just like that meme of a manager showing a graph and saying, oh, hey, we've had lowered our people having problems with our servers after we turned off the feedback page.
You don't get bugs if you don't track bugs, apparently. Yeah, so which goes to show that 99.56% uptime is actually like noticeably like worse than 99.99. But it works today. So yeah, so that's it. That's pretty much the entire workshop. We finished before time actually. Hybrid
So if
search.
you don't really like Jina, why do you use it?
Because I want to support the company. They have some really interesting tools out there. So for example,
Yeah, but no documentation, no.
well, so I'm a founder myself. I know how janky your stuff can be in the beginning, but they're like a research lab. So they have their own models, embedding models. They don't have LLMs, but they came out with like really useful tools recently for like web scraping, for like reranking. They'll get there eventually, hopefully.
Good. Supporting the research.
Their tools are great. Like when I've used them, they're awesome. They're
sorry,
super easy to use. Their tools are great.
Oh, yeah?
Like I use their reader and their scraper, and it's just super easy to use. It's easier than anything else I've ever tried. So, or at least it's ergonomics suited me quite well. Yeah, not ours.
Is your code available to?
Oh yeah, all this stuff's gonna be open source. I'll send it to you directly.
Okay.
Yeah.
You're going to include your API
Minus
keys?
your API.
I will include all. I didn't say that. Like I said, everything belongs to Invest Ottawa. I'm just kidding. I'll tell them. You gotta rotate these keys. But yeah, that's it. That's the workshop.
Is Weaviate free?
Weaviate, you can create a sandbox, and then if you want something in production, you have to pay like $25 a month or something. Yeah. But Supabase, PGVector, TSVector, it's free. And if you reduce your dimensions down, you can keep it for a really long time. Yeah, it's gonna blow up at some point. My setup is gonna blow up. But yeah, thank you all for coming. I will send you all the code later tonight. Thank you.